Alright, welcome back. This is your notes for Friday. This is 9.4. We're going to do area and perimeter of parallelograms on the coordinate plane today. So, we are now moving to shapes that you pretty much probably have not dealt with before. Alright, so you may recall from our day 2, 9.2, that a parallelogram is a quadrilateral with both pairs of opposite sides parallel and congruent. So what that means is this, is that I know that this side is parallel to this. I know that this side is parallel to this side. Remember those arrows are saying parallel, right? And they're also congruent. So I know that this side is congruent to this, and this is congruent to that. And that's everything I know by calling it a parallelogram. You actually already know the formula for the area of parallelogram. It is the same as a rectangle, and that is area equals base times height. Alright, so, but how can this be if they're different shapes, right? Well, I'll show you. So we're going to use the given parallelogram to explain how this formula, for the area parallelogram, and the area of the rectangle can be the same. Okay, now I'm going to erase these little tick marks because I don't want you to get lost in what I'm ready to do. Okay, so here in a second I'm going to transform this into a rectangle, and I'm going to show you how I'm going to do that. So I can transform, and this is parallelogram AB, not triangle, A, B, C, D into a rectangle, and I'm going to call it A, D, E, and F. And I can do that here in just a moment. Okay? And how I'm going to do that is I'm going to cut off the front triangle, and I'm going to move it to the back. I'm going to do it by moving it to the back. Okay? So here we go. So as I do this, I'm going to change colors. What I said is I'm going to cut off the front triangle. So I'm going to do that by cutting off from A straight down. And remember, since BC is a horizontal line, if I draw a line out of vertex A straight down, which means it's perpendicular, it's a vertical line. If I draw that, I want to cut off this front triangle. Okay? I can do that by cutting that. Now, I'm going to relocate it to the back, which means I'm going to come out of the vertex back here, and I'm going to bring it straight down. And in essence, if I connect C all the way out to here, so I make this my E, and this my F, where I connect here, I am now taking what I had in yellow, this little area right here, this front triangle, and I'm going to put it on the back side, the exact same right triangle. And what happens is this. When I do that, I create rectangle AD and E and F. And now I just created a rectangle. And in essence, what I'm trying to tell you is this, is that parallelograms do not have right angles. So the height always must be drawn in separately to create a height that is perpendicular to the base. This thing right here, that I'm highlighting right now in orange, is huge for you. Because on a parallelogram, I can't just use a sidewall. It's not perpendicular to the base. I must draw in a height. Well, I can do that out of any of the vertexes. Okay? So, let's see it. Okay? So here we go. Analyze parallelogram ABCD on the coordinate plane. Which side do you want to use as the base? Well, when I look at this, I really notice that BC and AD are horizontal lines. And AD is a horizontal line on a even number. It looks like 3.5, right? So I want to use AD as my base, right? So I'm going to say AD, that's line segment AD, is the base. And the reason why also is that it's down here at the bottom. I can see it nice and clear. This is where it is, right? It's actually at the bottom of the figure. So that's really kind of cool that it forms my base. It's just like the floor that you're sitting on right now. That would be our base, right? Now it says describe how to place the height. Well, when I see this, I know that AD is a horizontal line, so I can draw a vertical line down to AD, only because AD is a horizontal line. So I can draw a vertical line, and the reason why it has to be vertical is that it's going to be perpendicular to the base, right? And I'm going to do that from vertex B. And the reason I'm choosing vertex B is that it's inside the shape. Notice that if I come from B and I come straight down, I'm actually inside the shape. It is much easier to see, okay? And I've drawn my 90-degree symbol in there, right? That little box tells me 90 degrees, okay? Now the line is vertical from vertex B only because AD is a horizontal. Remember, and I'm going to label this E, okay? So this becomes E down here. So that point right there is E. So remember that BE is perpendicular to AD because AD was horizontal and BE is vertical, right? If it was slanted at all, if AD was slanted like AB is, see how AB is slanted? If AD was just like AB, I would not have been able to draw this in, okay? So, here we go. I know, what do I know? Well, let's find the points. I know that B is at negative 2.5. And what is that? Negative 1.25. Negative 1.25. Okay. And I know that E at this point, E is at the same negative 2.5. And it is also at negative 3.5, okay? And so, determine the base and height of parallelogram ABC. So I know those are my points right there, right? So, I can count for AB and I can count for BE. In AB, or AD, sorry I said B, AD, A to D is going to be 4.75 when I count it. From left to right, A to D is 4.75. And when I count from B down to E, that is going to be 1.75. Now remember that I know that AD is congruent to BC. And I also know that AB is congruent to CD. Remember, I know these because it's a parallelogram. I have defined it as such. All right. Now it says, determine the area and perimeter of parallelogram ABCD. If necessary, leave answers in simplest radical form. So I know that the area is going to be base times height. I know that perimeter is add up all four sides. Add all four sides, right? Add all four sides. So I know that, right? So here we go. I know that A, I'm going to put this over here, A. We've already said, we have not said A. Where's A? A is at negative 4.25 and negative 3.5. And I know that B, we've already said where B is, negative 2.5 and negative 1.75. Now remember, I only need to find AD, which I have already, it's 4.75. I need to find A to B, one of the side walls for perimeter, right? So I'm only finding the distance of AB to help me find perimeter. I already have enough for area because area is base times height. In my red line, my BE is my height and AD is my base. So let's do that real quick. Let's do area first. So area is going to be equal to 4.75. And that's going to be times 1.75. And my area is going to be 8.3 units squared. All right. Now that I have that, I'm down to perimeter, which means I really just need to find AB because I know CD is the same as AB. And I already know that BC is the same as AD. That's 4.75. So far I have 2 out of the 4, and once I find the third, I have the fourth. So let's find the distance of A to B. So AB equals distance formula, the square root of x squared minus, or x2 minus x1 squared plus y2 minus y1 squared. So AB, A to B, negative 4.25 minus a negative 2.5 squared plus, and I started with a 4.25, so negative 3.5 minus a negative 1.75, and all of that squared. Two negatives make it positive, two negatives make it positive, and underneath there I'm going to get 1.75 for the x's. And I'm going to get 1.75 for the y's as well. And all that's squared. And I'm going to get the square root of 1.75 squared plus 1.75 squared is 6.125. Now, simplest radical form. That is going to be simplest radical form because it's a decimal, right? So let's find the perimeter. So my perimeter, and I'll do it in a different color. My perimeter is going to be, remember, AD is 4.75. So 4.75 plus 4.75, because I know that BC is the same. And then I'm going to add it to the square root of 6.125 plus the square root of 6.125. Now, I want you to go ahead and I want to change this a little bit. And I want it in nearest tenth. So you can go ahead and rewrite this up here and go nearest tenth. And the reason being is that I don't want to make it to where you can't do this because you see crazy radicals and you're like, oh my God, I'm going to shut down. So let's just put this into our calculator and solve. And so if I put 4.75 plus 4.75 plus the square root of 6.125 plus the square root of 6.125, I should get, when I'm done, 14.4. And this is going to be units, and just units because I'm not multiplying units together. All right, so there's that. I found the area. I found the perimeter of that. So let's move on to one that may be just a little bit more difficult. Here we go. And you're going, oh boy, something more difficult. Well, it's going to be difficult because it's not going to be straight lines, and you'll see that here in just a moment. Okay? So, it says, graph parallelogram ABCD with vertices at 1, 1, 7, negative 7, 8, 0, and 2, 8. I want you to go ahead and do that now. Graph this parallelogram. So A is at 1, 1. B is at 7, negative 7. C is at 8, 0. And D is at 2 and 8. All the way up there. And then I want you to connect these vertexes. And if you need a ruler to get them straight, then use a ruler. You know where they are. Do not freehand this if you can't draw straight lines. Do not freehand, especially with what we're getting ready to do. So, we have these. Now, what do we know about this? We know that we defined it as a parallelogram, correct? Yes. So, I know that this is congruent to this. I know that this is congruent to this, right? And I know that because I defined it as a parallelogram. So now it says determine the perimeter, if necessary, round to the nearest tenth. Leaf side lengths as radicals. So here we go. To find the perimeter, I just need to find the distance of either, I'm going to say this, perimeter. I need to find the distance of AD or BC, but just one of them. And I need to find the distance of AD or, I'm sorry, not AD, I've already said that. I can't see my hand. AB or DC. And it's either one because I know that opposite sides are congruent. So let's just do, I'm going to do AB and I'm going to do BC. Okay, AB and BC. So here we go. AB, the distance, is the square root of, you got it, x2 minus x1 squared plus y2 minus y1 squared. Remember, I promised I would write it every single time because I want you to learn it. Here we go. A to B. Now, A is at 1, 1 and B is at 7, negative 7. And I'm just using these up here. I can see them up here. So that's why I'm using A to B. And then the next one is just B to C. And I'm kind of doing that because I can look at it up there. So, A to B, 1 to 7. So 7 minus 1 squared plus, and that is going to be negative 7 minus 1 squared. So AB is going to be 6 squared plus negative 8 squared. So AB is going to be 36 plus 64. Ooh, look at that. AB comes out to be the square root of 100. The square root of 100. 100 is a perfect square of what number? 10. So I know that AB is 10. So I know that DC, right, yeah. AB is 10 and DC has to be 10. Yee. Now, let's do the next one. I want BC. B to C. You got it. The square root of x2 minus x1 squared plus y2 minus y1 squared. B to C. B to C. Difference of x's. 8 minus 7 squared plus, I started with 8, so I'm going to go 0 minus a negative 7 squared. Negative, negative, make it positive. So B to C, 8 minus 7 is 1. So I have 1 squared, and 0 plus 7 is simply 7 squared. So BC is the square root of 1 plus 49. So BC is the square root of 50. And we should know by now that the square root of 50 is simply 5 square root of 2. 5 square root of 2. So I know that AD is the 5 square root of 2. Let me get that in. I'll put over here BC. 5 square root of 2. And AD is the same thing. Remember, I know that AD is congruent to BC, and I know that DC is congruent to AB because we defined it as a parallelogram. All right, so what next? It said determine the perimeter. So I got to find the perimeter. Here we go. Let's do it in black. So the perimeter of that, and I didn't leave myself much space, but I can just do it. Add both tens. Why won't you write? It's part of my problem. My pen's kind of crapping out on me today. And I know it's 5 square root of 2 plus 5 square root of 2. Remember, it said nearest 10, so I can put that straight into my calculator. And it will do all the work for me. So my perimeter is 34.1 units when I put it into my calculator and do it. All right. Now, it says UCD as the base. Okay? UCD as the base. How will determining the height of this parallelogram be different from determining the height in the last example? Well, let me change color so you can see when I write. Now, you've got the perimeter down, so I'm going to go ahead and erase this real quick to give myself room to write, because I think I'm going to end up getting into this area. So, okay. Well, since CD is not horizontal nor vertical, what is different about it is I cannot simply draw the height in. And the reason why is that neither DC or AB in this matter are vertical or horizontal lines. So I can't simply just draw a height from A to DC or from B to DC. And really I'm going to use it from A, I do believe. And we're going to go from there. Okay? So when I do this, we're going to have to do something a little bit different. And hopefully you're starting to understand what we're going to have to do. Hopefully you are remembering that we're going to have to find the slope of CD. Because if I need a line that's going to be perpendicular to it, right, the height has to be perpendicular to the base. So if CD is that, since it's slanted, since CD is slanted, it's not horizontal nor is it vertical, then I must draw the height from A to DC, but it can't be simply it's not a vertical line. So I'm going to have to find the slope of CD. Remember, the slope formula is y2 minus y1 all over x2 minus x1. And I know that C, where is C at? C is the point. All right, M equals C. Was at the point 8, 0. It's off my paper, so I'm trying to draw it right here. And D is at 2, 8. And I've got to find the slope of that CD. So, C to D. Let's go 0 minus 8, and 8 minus 2, that's equal to negative 8 over 6. If I reduce that down, it's a negative 4 over 3 if I take both a 2 out of 8 and 6. So, I have found the slope of CD, which is negative 4 over 3. So what is going to be the slope of the line of the height? Well, I'm going to call the height A to E because I'm going to come out of vertex AE. I'm going to come out of vertex A. I'm coming out of this one right here. I'm coming out of A and I'm going to DC. So I'm going to come right out of there. Now, when I do that, I know that I've got to find the slope of AE in order to draw it in. Okay? So I know that the slope of AE has to be equal to the opposite reciprocal of negative 4 over 3. So it has to be, flip the fraction and change the sign. It has to be a positive 3 over 4. So my slope of AB has to be 3 over 4. And that's positive 3 over 4 because it's the opposite reciprocal of the negative 4 over 3. All right. So remember that the height must come from a point, usually a vertex, which we've already talked about. We're going to come out of vertex A on the side opposite of the base. Use this information and the slope of the height to plate the height of the parallelogram. We're going to do that right now. So I know that my slope is 3, 4. I'm going to try to do this in a color that you can see, because I've got a lot of color going up here. So I'm going to be in green. I know the slope that I'm going to go up is up 3 and to the right 4. Up 3 to the right 4 as I do this. Ready? I'm going to draw it in green as I say it. Up 3. 1, 2, 3. Up 3. To the right 4. 1, 2, 3, 4. I actually hit the line right there. And I hit the line right at 5, 4. Oh, I don't want to draw it there because I'm going to draw my height in. So my point, which I'm going to call E, I'm going to call this E, and I'm going to get rid of this 10 for right now. I'm going to call this E, is at the location 5, 4. My height is from A to E. Let's draw this with a different color. A to E is right there. That is my height. That is my height. A to E. It's at 0.54. So, we have drawn that in. Now remember, I simply count my slope to find to the other side. So I went up 3 and to the right 4 from vertex A. All right. So we've done that, right? So now it says label the point where the height intersects the point at base E. Well, we've done that. That is going to be at 5, 4. So we did that already. Whoa, where'd you go? So we did that at 5, 4. So good, we've done that. Now determine the base and height of parallelogram ABCD. Well, we know that the base already is our CD. We discovered that. We've already decided that. And we know that it's 10 units. We already know that. We've already found it, right? So now that we know that D is at, or no, A is at 1, 1. So I know A is at 1, 1. And E is at 5, 4. And I know that AE is going to be my height, right? AE is my height. So we got to find the distance of AE. So AE equals the square root of x2 minus x1 squared plus y2 minus y1 squared. A to E. X's. I'm going to do 5 minus 1 squared plus 4 minus 1 squared. A to E. This becomes 4 squared plus 3 squared. A to E equals 16 plus 9. Oh, this is going to come out nice. 16 plus 9 is 25. Square root of 25 is 5. Yee! That's nice. Nice even numbers, no radicals. You guys should be ecstatic. So let's determine the area parallelogram AB. CD. Here we go. So area equals base times height. I know my base is 10 and my height is 5. We just found it. AE is my height. So my area is 50 units squared. All right. Hopefully you got that. Make sure you can pause and rewind and go through it if you like. But there it is. All right, turn the page. Last page, last page, last page. It says graph parallelogram ABCD with vertices at -7, 8, -3, 11, 5, 11, and D is at 1, 8. Go ahead and do that now. So -7, okay, and 8. -7 and 8. It's going to be right there halfway through. -3, 11, which is right there. 5, 11, right there. And 1, 8, right there. Connect those. And so A was right here. B was right here. C is right there. And D was down there. All right. Now it says determine the area of the parallelogram. Well, I know that area is going to be base times height. Now, I look at this. I want to make my base. I want to make my base AD. And why do I want to make my base AD? Those of you who said because AD is a horizontal line and I can count it is absolutely right. Hopefully you said that in your head somewhere. Hopefully someone did. So I know from A to D that's going to be 8 units. 8 units. Nice and easy to count. Well, the other great thing about the fact that we can count that because it's a horizontal line is this. I get to draw my height down from vertex B down to AD because AD is horizontal and therefore a vertical line is perpendicular to a horizontal line. So not only do I get to count my base, I get to count my height as well because if I drop this right here, I know that that is my height. I'm going to label that E. So I know that BE is my height and that's going to be simply 3 units because it's countable from 11 down to 8. So if I do this, I can find my area pretty quickly. Area equals base times height. Area equals 8 times 3, or simply 24 units squared. All right. So the next part of this says you want to double the area of the parallelogram by manipulating the base. Describe how you would move points to represent this on the coordinate plane. Well, I could translate, which is basically move, right? Move. Vertex C and D. Now I can move that. Well, my base is 8 already, right? AD was 8, so I would need to move it. I need to translate it 8 units, right? Or I could move vertexes A and B 8 units, not right, but left. I could do either one. Either one, but not both. I can only do one or the other. One or the other. Okay? So, let's manipulate parallelogram ABCD as you described in part B to double the area. Label the image and identify the coordinates of the new points. So I'm going to do C and D. Okay? And the reason why I have to do both is, remember, it's a 4-sided shape. It's not 3. So I can't just move one. I've got to move both. So as I look at this, I'm going to move C out 8 and I'm going to move D out 8. So C is going to end up at 1311. and I'm going to make that C prime. And D is going to end up at 9, 9, 8 when I put it on here. And I'm doing that mathematically just because it makes it easier for me. And this is going to be D prime. So I'm going to pull that out and that out and connect those. And that's my new one. So I said that I moved C prime out to 13, 11. And I moved D prime out to 9, 8. Okay? And that's what I did. And I've labeled it. So my new parallelogram right now is at A, B, C prime, D prime. Alright. So now determine the area of the manipulated parallelogram. Well, the only thing I've changed is my base and the length of my base. I didn't change anything with my height, right? So this is going to be area equals base times height, which means it's now going to be area is equal to 16 times 3, right? 16 times 3, or, right for me, or 48 units squared, right? Because why? Well, AD and BC became 16 instead of 8, right? Yep. All right, here we go. E, looks like the last problem. Parallelogram ABCD is given. Double the area of the parallelogram by manipulating the height this time. Label and determine the area. All right, so let's do this. Well, we know right now in its current state that the height is 3, right? I'm going to label that E. And we know that that is currently 3 units up, right? 3 units. So we know that BE is equal to 3 units. And I probably wrote that in the wrong spot. I probably need to write it over here. So BE is equal to 3 units. So here we go. And it wants me to double the height by manipulating, or double the area by manipulating the height. So when I look at this, I'm going to move that up another 3. And I'm going to do this in a different color so we can see it. So I'm going to go up by 3. And it means I'm going to go right to here. And that's going to be my new B prime. But you all know that I can't just do one, right? I've got to do both B and C. So C has got to go up as well and come up here as well. And this becomes C prime. So now I have A to B, D to C, right? And AD is still connected, and then I connect that. And you're going to see that right there, right? Now I'm going to take out the line I drew up just because I want you to see that it's the new parallelogram, right? That it's there. Now remember, we knew we went up 3, right? So what I've done is that I have moved B and C up by 3 units. Okay? Therefore, making the height 6 units. I've now made the height 6 units. So, now we can do this. Area is it going to be 8 times 6, or area is going to be 48 units squared. All right. Questions? I'll be back on the 24th. Hopefully, if you have some, you'll be asking. Understand that you need to be working. Pause if you need to. Rewind. Do whatever you have to do. There's only one more lesson after that, and then we're getting going. So, good luck to you. Have a great spring break. Hope you enjoy your time off. See you on the 24th to 25th.